Okay, so today actually I planned like one half is just introduction of trigonometry, and the other part will be some exercise. On Monday we will have a quiz. So the quiz will be about polynomials and also the logarithmic and exponent. So I will maybe I can just get through the trigonometric really fast. Maybe just an introductory and just to review which part that is important and still relevant to for most of the case in the future courses. So in trigonometry, I will start with we call this a right triangle. Okay, and then later we can see how we can use trigonometry in more analytical way by using some identity and so on and so forth. But first, we are going to start with if we have an angle, like if we would like to state that in terms of a graph, we always start from what we call this is what we call the polar axis. Okay? So it doesn't have the y-axis, so it only has one axis. We call it this horizontal one. And how we move this angle, or how we define the point within the this approach. Usually we say that this is like a polar coordinate. So we are going to say that we have some certain, let's say, radius here, and then we move in a positive way. So when we move positive angle, we move counterclockwise. Okay? So counterclockwise. So we start from here and we go to the left. Counterclockwise. It means that we are going to plus having some increasing the angle. So the angle is increasing, means it's getting positive, positive, positive. And by the same reason, when we have like clockwise, it means that we have a negative angle. Okay? Negative angle. And we say that this first side is called the initial side, okay? And the end point, that is what we call the terminal side. But that term doesn't really meaningful. But the important point is whenever you have a positive angle, you have counterclockwise. Negative angle, you have the clockwise. And then to measure how much angle we have, is sometimes using the radian. So radian is somewhat, by definition, 180 degree means it's pi radian. And 1 radian means that it's ratio between 180 over pi in the angle, and 1 degree means that the pi over 180 radian. Okay. So we can convert based on degree to radian or radians to degree by taking this ratio. I think this is really basic. And also, it means that if we have 1 here, it means that 1 radian. Or if we measure through degree, we can convert based on 180 divided by pi, and we get around 57.296 degree. Okay. And also regarding this circle, if we would like to, if we cut this and then we stretch this side, we have some length. That is also special length that we are going to, I think we are going to see a lot, I think later on in calculus. So let's say this is equal to S. Okay? This is what we call the arc length. Arc length. And how the arc length can be measured. Okay, first, remember that the circumference of the circle, we agree that this will be equal to 2 pi r, right? Okay. Now, the full circle, so let me write, full circle is getting 2 pi in angle, right? It's fully circles, right? So the S means will be a ratio of the angle, theta, divided by the full circle, multiplied with the circumference. So we get that the S is actually theta r. Wait. Oh. Why? Change this. So r theta. Okay. Or we could also rewrite this theta as theta s over r. So as long as we can get the arc length, and if we divide that with the radius, that will be our measurement of the angle. And aside from the arc length, we can also find this with the same ratio. We could find what we call the sector. So the sector is the area. So the area of the sector will be theta over 2 pi multiplied with the area of the circle, the pi r squared. So this will be half theta r squared. You will see this expression a lot when we deal with the calculus 2. Are you truly? Yeah. Okay, hi. Yes. Finally, second student. Okay. Private class. Okay, so we have the arc length, which is the S, the theta r, and we have the sector, which is the half theta r squared. If we are looking later in calculus, especially calculus 2, we're going to see a lot these two expressions, the arc length and the sector area. Which means that we are going to see some involvement of this r theta relations in calculus. Okay. So far, what we have in calculus is single variable, a function of x usually, or function of one variable. But in calculus 2, we are going to see there are we will have the multivariable calculus, which means that the variable will be more than one, and one of them is using this r theta. So using we call this a polar system or polar coordinates. And also in physics, we have the angular speed and so on and so forth. But I think I will not get into more details about that. I will just focus more now on trigonometry and the introductory of the polar. Okay, now, so that is our introductory, how to measure the angle and also how to relate the angle with the polar system. Okay. Now, I think just a quick review on how we get the ratio and how we name it. We start by sine, which is we have the triangle, and then we could have the ratio between all these three and we have all this combination, I think the best way to see is we just take sine, cosine, and tangent, and that will be the very basic one. Okay. The sine, I think if you check maybe from your biology books or maybe some dictionary about anatomy, inside your nose, we call it sine also. So it's like if you see the bones, it has like a curvy shape that we call the sine. Which we have if we have like some anomaly, sometimes the phlegm is stuck in those, and we call it the sinusitis, which means that it has some inflammation on that part. And basically what I want to say here is the sine is actually a word that describes the curve. Describe the curve. And I think it has also relation with the arrow and bow, like when you play on that. So I'm sure the Indian was the first one who invented this relation. When they maybe using the arrow, and then they are curious like how they can make this ratio, and then how can they measure the angle, and then the other part, the cosine, is just complementary of sine. Basically, that is cosine means complementary of sine. So they found like how if you see the graph like sine and cosine, we just shift the graph. We just shift pi over 2. Right? So that's how we get the name. And tangent is literally the slope, right? Divided by this, the slope, right? The slope. So that's also how we get the name. The tangent also means that it's only touching the one point, and it has like a slope like that, and then we can describe the slope based on the triangles. So I think it's very, very, very intuitive, and also you can apply it for most of the cases. Some special values of the trigonometric function. So we have some special values that we usually describe. So I think we can just focus on these three, sine, cosine, and tangent. And we start by 30, 45, 60, and 90. So whenever we have this, I think we're good to go. Usually we memorize this when we are learning the trigonometry. I think useful. And there are some, how to say that, in transformation, like if you can draw the graph for sine, cosine, and tangent, we could also transform the function by shifting the graph. So we can shifting through vertically, meaning we add with some constant, or we can shift horizontally, just like we did in the functions chapter. We can shift it to the right or to the left, and basically for sine and cosine, there will be. So sometimes we could say that if we shift it pi over 2, the sine will be the cosine. Okay. Okay. What else? That is. Hi.
Yeah, yes, sir. Just something with our.
Okay. And then I forgot one more thing here. That's supposed to be introductory as well for trigonometric. So our plan today is just overview on trigonometry for a while, maybe on 30 minutes, 40 minutes. And then after that, we can have some practice for quiz. Monday will be quiz. Okay, so another thing that is important is the conversion. Okay, so conversion. Oh, maybe it's polar. So we start with the. We say that if we have this, let's say this is x, y, and let's say we have some point here, p, and we would like to describe this p not in the Cartesian but in polar system. So we have r, the radius of the p, and then we have the angle. As I said at the beginning, that whenever we have let me write. Okay, so whenever we have increase in the angle, we move counterclockwise. Okay. That's positive angle. If we move clockwise, we have negative. Okay. Okay, so we would like to say that the point on xy or the Cartesian system, we would like to change and convert to the r and theta. So how to do that is basically we could imagine that this is a triangle. So you will see that, or maybe to make it clear, let me erase this. Maybe the triangle I will work out in the first quadrant like this. Okay. So this is P, this is XY, and this is theta. And if we have, let's say this is an X, this is Y, so the sine theta will be Y over R, cosine theta will be R over Y, and we need to make sure Y is not equal to 0. And then, oh, sorry, this is X. This is tangent, sorry. Let me erase this. That is tangent y over x. X is not 0. Okay. And then with all the counterparts like secant, cosecant, and cotangent. Okay. So we could write y as r sine theta, and then x as r cosine theta, and then the tangent is the slope and also the circle. So we could have x squared plus y squared equal r squared. Okay. So using these three relations, y equal r sine theta, x equal r cosine theta, and then the circle equation, we could transform the xy position or a Cartesian system into the polar. And especially if we have a curve, like if we describe a curve here, we could also convert that to the polar. And that will be, I think, one of the, mostly we are going to discuss a lot about this conversion in calculus 2. Okay. And then another part that is important here. So based on this conversion, we could also try to map what we call the quadrants. So this is the quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay. The first quadrant, we have all positive values for all. So for sine, cosine, and tangent. For the second quadrant, only sine that is positive. So the other one will be negative. And the third quadrant is only having a tangent that is positive. And the fourth quadrant only cosine that is positive. And how exactly we know which one is positive and negative? Actually, you don't really need to memorize that. As long as we understand that this is like an XY Cartesian system, and then we know that the relations between XY is basically sine and cosine, right? So sine is related to Y, or here Y, and then cosine is related to X. Okay. So for the first one, it's, I think, very intuitive. XY is positive, right? So all positive. Okay. Here, which one is negative? X, right? X negative. So X negative is what? Cosine. So that's why cosine is negative. So because cosine is negative, sine positive divided by cosine negative, negative. So only sine is positive. Okay. Tangent positive. Negative X, negative Y. Negative sine divided by negative cosine, positive, right? So actually very simple. And fourth quadrant, it only has like X here that is positive, which is cosine, right? The sine is negative, and because that is negative, positive divided, a negative divided by positive, it's negative. The tangent negative, right? Easy, right? I think I had experience like I need to like remember, oh, in first quadrant they all positive, and I need to memorize all the things. But then I remember this is just like a plain Cartesian system, like X, Y, and when it is all positive, okay, all positive. This is only Y that is positive, which is sine, and all will be negative, right? I think that will be a good way to understand rather than memorize. So that will be like we can memorize really well if we understand. Like if we blindly memorize, sometimes if we forget, then like it will not be stuck in our head like for a long time. But if we know how and then we kind of relate to that problem, then we will remember for forever. like a traumatic, but like in a positive way. Like a trauma in the positive way. Okay, another part is another part is the identity. This is identity that I think will be important. You can write this first and then we can learn. I'm not sure why now they are getting cropped on the left side. I think this is some kind of bugs because before it's not like this. problem. Okay, we have the reciprocal identity, which is the definition for the cosecant, secant, and cotangent, which is related to the sine, cosine, and tangent. We have the tangent, and then we have the cotangent, which is just reverse one over another one. And then we have Pythagorean identity. Okay, I think I will have some special, maybe next 2 weeks. We can not next Monday, but after Monday. After that, I think I can give you some idea how we can understand all of this identity, and then the odd and even. This is practically the easier way to remember this odd, even odd identity. Remember that when we have negative x, we have negative angle. We move the angle clockwise. So more or less, this negative x is on the fourth quadrant. Okay. So when we have the fourth quadrant, which one is the only positive one?
In the
Fourth. Yeah, that's why it's positive. The other one is negative. Okay, makes sense. Okay, and then the other one is the cofunction identity, which is basically this is what we call the shifting in transformation of the function. Sine and cosine is if you change the functions and we shift it horizontally, it will be changing sine to cosine because they are basically complementary with each other. Okay, and then similarly with the other one as well. Okay, I think that is just introductory for the trigonometry, and I think I will move to our quiz preparation. And not only for like a quiz preparation, but also like it's like a basic math preparation on, especially for the polynomials and the logarithm and exponent.
Professor, I have a question.
Yes?
Do we have a final test for classical math?
Yeah, I think we can. It will be like a comprehensive test.
Comprehensive?
Morning.
Morning.
Who's that?
Yeah, I mean like for whole chapter.
Morning, Professor.
So there will be exercises, right? Like a normal final quiz.
Should be, but not. The comprehensive test means that the test will be like very accurate, but it will comprise for all chapters.
So good.
Like at the beginning, we should have like one test first. I forgot to apply that if you like pass the test, you don't really need to come to the class. So I should make that one as the first, I think, or maybe the second class.
No, but they made us take a test.
I mean, that's in maybe some of the students, they don't take the test. They skip and then they need to take the basic. But like sometimes if you do the test like without any preparations, maybe you mess up. But if you like prepare a little bit, maybe you can pass the test. So I think like maybe for next year I need to make it at the beginning like a comprehensive test, just an average question for most people, and if you pass the test,
Maybe
those students, they may need to take for some time, like if they want, but they don't really require to do that. I think they will be okay for that.
because we're talking about that. I remember when we received the document to prepare for the exam, and it was difficult.
Yeah, it was the I know.
No, maybe it was. I don't know.
It's always difficult.
Oh, so yeah. No, like we just decided now we're not gonna do it because we don't know if it's gonna be this hard.
And sometimes our identity program only one or two podcasts that only one or two usually.
Oh,
Yeah.
makes sense.
Like every year, like maybe 1 or 2. I think we have like 1 year, 3. But most of
That's
the
the record.
Yeah, most of the time 1 or 2. 1 or 2. I think one time is 3. I think 3 equals 3, 2 years ago.
Professor, how do you thought about the date of these final tests?
I think like 1 week before Christmas. Is that Monday or Tuesday? I forgot. But I think between the and for you, I think
Yes, that's all chemistry final. That's all chemistry final.
Okay. Oh. Or I think we can
Just
book-
erase the
Let's
or
just
we can borrow class and take another day. I think that would be because chemistry, I know you will struggle a lot. Okay. I think we can move to this part. Where's picture? Okay. So quiz preparation. So we start by polynomial. You can check and try to work it.
¿Cómo se dice? Entonces tenía que dividirlo con el tiempo. Ay, no, este fue con el diagrama ese que es así. Sí.
División sintética, valor artificial.
Y se tiene que ver con el último número y el último cuarto factores que se pueden dividir y
Por
empezar
eso.
a probar. Pero hay una manera de determinar los números sin necesidad de estar probando, pero no recuerdo nada.
Anyone still have a problem like solving like this kind of like finding the roots or the solution?
Maybe it would be good for us to like, no, like how do you say, like review, not exactly how to do it, but like the steps.
Like
So-
which one is like how to do the
Like,
first
what are the
step?
first steps?
Okay.
That's usually
Okay. I think for all polynomial cases, if you are looking for a real solution, if it is quadratic function, I think it's easy, right? Just finding how to factorize and if the function can be factorized. But now is sometimes when we have like cubic or maybe higher degree, what we can do is first see the last coefficient and the first coefficient. Okay. So from 6. So let me write here. So from the 6, we have some factor, right? We have plus minus 1, plus minus 2, plus minus 3, plus minus 6, right? This is all the numbers that can make up into 6, right? Either 2 by 3 or 6 by 1. It can be 6, right? And then we have 2. We just only have 2 numbers, right? 1 and 2. So usually, I will set up this as a P. This is Q. And we are going to have like P over Q. So we have like, we call this a rational zeros. So we have plus 1, 2, 3, 6. And we have 1 and 2. So at least we have combination of this. So we have 1, 2, 3, 6. And then we have 1 over 2. 1 is already there. 3 over 2. Yeah. So we have 4 and 2, so we have like 6 combination with positive and negative. And then is the number that we are going to select. If, however, if we see that maybe that is still too much to to select. Maybe we could like narrow. And how to narrow it? And basically it's just like a prediction. So you can see the signs. You see this is positive and this is optional. You can just directly just try and solve. This is positive, negative, one change, and then we have another change. Okay? Two changes. So which means that in the positive zeros, there will be 0 roots or 2. Okay. So we will have. Let me write here with this color. This is 1. This is 2. So it means this is 0 or 2 positive. You could try the negative, which exchange the x. So we are going to input negative x inside. So this will be the same. This will be 7. And we are going to see that we have exactly 1. So it should have 1 negative zeros. Remember how we get 0 and 2? Whenever you have more than 1, like 2, 3, 4, you need to minus with the even whole number. Minus 2. So if you get like 5, you have 5, 3, 1. So 3 distribution. So 3 cancels. But if you have just 1, so there's only 1. So it means that we should have 1 negative zero. So we need to select the negative number. Okay, do you understand what I mean?
Yeah, I understand, but can I ask why it's like, it's just some of the terms change the sign and not the other?
Negative x, put cube, put here, negative, right? So negative. Negative x going to x squared is positive.
Won't change.
Okay, no change, right?
Oh, okay.
Positive, negative is still negative.
Oh, so it will depend on the the way of the.
Yeah, of course. Okay. Get it? So negative 0 is only 1, which means that we can select negative 1. So we can maybe if we check negative 1. And how to check? We could use the how to say that the synthetic division. So we have 2, or maybe let me write around here 2, negative 1, negative 7, and 6. Okay. And then we put negative 1. 2 multiply negative 1 is negative 2. Negative 3, right? And then we have 3. I think we don't get it, right? So we erase again. Literally, I also don't know like which one, so I just check one by one. So we check negative 2. So check negative 2. So 2, negative 4, negative 5. Okay. What this will be? 10. 10 minus 7 is 3. Oh, we get it. So we get it 1.
So okay. Since this is the first, since we only have 1 negative 0 and we already have the answer, we don't have to do the other numbers, right?
Yeah, sometimes we need to do, but for this case, because this is a cube, we have 1, so the other one will be quadratic, right? That maybe we can factor it like as usual. So we get this is negative 2, which means this will be x plus 2, right? And then multiply with 2x squared minus 5x plus 3. Okay? So this is our function. So this is px becomes this. So since we have this px, we try to factorize this. And as I mentioned, we can try this out. So 2x, and this will be, I think, negative 3 and negative 1, or Maybe not this one.
¿Existe eso?
Maybe 3, 1. Is this okay? Is this correct or no? -1, -5. Yeah, -2 is correct, right? -2, -3 is -5. Okay, I think we get it. So we could write the px as x plus 2, 2x minus 3, and x minus 1. So we have x -2, x 3/2, right? X equal 1. Exactly as we predict. We have 2 positive zeros. We have 1 negative zero. Well, if you feel like confusing on this very design change part, this is one step that you can skip. You can directly just check one by one. Okay. Check from the easiest one, 1, -1, 2, -2, 3, 6, and then 1/2, 3/2. Sometimes 3/2 takes some. If you put this in like a fraction here, maybe not really that simple. Sometimes.
Professor?
Yes.
For the part that we have to find the positive and negative zeros, if it is positive, it's going to be 0 or 2, because it's not only 2, because we can have
Imaginary number.
no.
Yeah, you might have that.
So that's why it's 0 or 2.
Yeah.
Because in the
You can have like a possibility to have an imaginary.
that's why it's 0 or 2 zeros.
Yes. Like the polynomial is not always like real number. Sometimes it has like imaginary. Okay.
Professor, just in case, do you have any kind of example with like exponential?
What kind of explanation?
So this was never meant to come out in the quiz.
You mean?
Yeah. No, because last time I was studying this for the quiz, nothing came up. So did you mention that this was not completion?
I think we are going to have.
No, in the previous quiz, we didn't have anything to do with this.
Previous only function, right?
Yeah.
Right?
Yeah.
Function, right? Only function. And transformation, something like this. And circle line equation, I think that is your first quiz. This polynomial will be the next. So polynomial and the log. Excellent. So 2 chapters. So what kind of
We were talking about something before, because we were stressing about this, that there was values like E or something like that.
yeah, that will be in exponent. Yeah, the sign of change. Basically, first we check this, the positive x. We see we have 2 change. So it has 2, means that we have 2 or 0, the chances that has the for zeros to have. That means that it's for positive zeros. If we change the x into negative x, like this one, it means that this will be for negative zeros. Positive negative means the number that we choose as our prediction for 0. Then we check through here. But since this is only 1, so for sure it must be negative 0. There will be 1. So I think we can just check the negative. So we can check negative 1, negative 2, all the negative numbers. And then we get the result. Oh, this is the factor. Then we could write the new, after we factorize the x plus 2 outside the function. And we have this, which we can factorize using the standard factorization. Well, of course, when you get like positive and negative 0, you can also check the positive one, but we still have like a 2 possibility. Like it can be also not like if, for example, if there is no real 0, then that means that you will not get anything. But I choose this one negative 0 because statistically this will be more probable to appear in our solution. Do you have my idea? So like it's like logical reason why I choose the negative first to check. But somehow, for some cases, maybe it will be 0 and 2. This will be also 0 and 2. So it's not useful. So you can just check all the numbers. But I always check from the simple number that is easier to be distributed in this syntax simplification. Because if you start with fractions, maybe not so good. So you just start with a simple number. Okay. Interesting, right? Or no?
Okay,
No.
So always it would be like when the question asks us for found the real zeros,
Mm-hmm.
not always have to be like 3 real answers, right? Not always it's like 3x.
Yeah, not always. Okay, not always. Sometimes maybe it has like imaginary situation. Okay. Okay, that's the first question. I prepare some of the question, but if we don't have time, I will just put all compile and give to you, and you can review by yourself. I have the other one is this. Maybe this one. Okay. Okay, we have a polynomial and we have a constant k, and we are going to determine k if we know that the factor, one of the factor is x plus 2.
When they say it's like it's a factor of px, we can say that like,
It's
minus 2 is every 0.
Yes, correct. That's the first thing you need to observe. When you read that the question has a factor, so it mentioned the factor, which means that this x minus x equal minus 2 is the real 0. So which means if we put into the equation, it will equal to 0. Okay? So I think give you something. So that's the first thing, and then after that, the second question is just to write the linear factor, which is this x plus 2, and then the other part we call the irreducible factor, which means that this is supposed to be, if this is cubic, then if we have linear, the other one will be quadratic function. Irreducible means that we cannot factorize. So it means that it's factor until you cannot like factor anymore. So I think you just write the factors. So first this is just to write on the, this is b. So negative 8 plus 4 is 16, right? And plus or negative 14 plus k equals 0. So this will be 8 and negative 6, so k is 6, right? And that's it. And the rest of it is, we could write, maybe let me write on the top. We have 1, 4, 7, and 6. And we know that negative 2 is our factor, so we have 1, negative 2, 2, negative 4, 3, negative 6. So we have the px is x plus 2, x squared plus 2x plus 3. And that's it. Okay.
Okay, so this is all the things that I'm explaining.
Easy, right?
It's not.
Huh?
It's not that. That's it.
Yeah, that's it. I think this will be very similar, so I will skip. Okay, I will just give to you later. How about this? So to understand the question is you need to understand what is the quotient and remainder in terms of the polynomial expansion. So we have the function. We define it with this.
Professor, is this meant to be on Moodle?
You mean,
The practice exercise?
yeah. Okay. So this part is just to write up. Just to write up the. So the f of x divided with x squared plus 1. It's become, the quotient is 3x minus 1 plus remainder is 2x minus 1 over the x squared plus 1. Okay, so this will be, so p of x equal quotient, or this is dividend, plus r. Okay, this is the standard. So what's the idea is just to multiply and then finding the f of x. So we can write f of x is 3x minus 1, multiply this, and plus 2x minus 1. And we just multiply this, okay? I think you can do it, right? I just leave it to you. You just multiply and then that's the function.
was just gonna try like the reverse engineering the target.
Oh yeah.
Try to include like everything, leaving the very first part and just
Yeah.
going back to that.
Yeah, I think you just use the definition of the polynomial division. Okay. I think I will move to the logarithmic. Is that okay? And the other one is like this. I think this is, we have done this like last time, but this is a little bit more complex. But it's still the same principle. I think last time you get this, but I will skip this one, okay? So you can try at home. Logarithmic, which one? I think maybe the first one. Okay, the first one. Would you like to try the first one?
Yes.
Do you think it's easy?
Yes.
I mean, solvable, right?
Yes.
Okay.
I just need to
So something like this will be like your quiz question. The idea is whenever you have a log with some basis, you need to try to make all equation have the same base. So you have log with base of 5, you have a constant. So you need to multiply the constant and change the constant into the log with base of 5. Oh, wait. I think I have a typo for the first one. Should be, sorry, it should be, I have a bracket here to make it simple. If not, then maybe you have like 5 with power of 4, right? So no, okay, I think this will be the question. I forgot to add the brackets. Oh, let me add the bracket, wait. Let me erase, and then let me write. Okay. So I think we can start by taking this. By the way, like I just realized like this semester that the keynote, if you are using the iPad or iPhone and using Keynote, in the Keynote they are integrating the system with the LaTeX. So if you like to write equation in math, it will be really good. I just realized that this semester. Keynote. It's the standard PPT on the Apple. Yeah, okay. If you use like, I think Microsoft they have, but it's not really intuitive using LaTeX. But here, it's basically just like insert the equation very easy and then just type in the LaTeX. LaTeX is something like this. If I like this code, I think it's very intuitive. In the Keynote, I just realized, so that's why I think I will use this for explanations. But the problem is when I wrote using the like Apple Pencil for drawing, it doesn't have automatically making line or something like that. So yeah, still good notes still. better. Before just like explanation for tutorial, I think this is also okay. Okay, I think we can start this by taking the 1 becomes log base of 5, and then plus 2, or let me write 2 becomes x squared, okay? So I will write this is log base of 5 x squared, okay? And we have log 5 16x minus 3. Okay, we have this, so we could write this, and we can combine, multiply 5x squared, and then we have 5x squared equal, and basically this is just a quadratic equations, which is 5x squared minus 16x plus 3. So we have 5x and x, and then we should have negative here to make it negative 15 and negative 1 here. Right? So we have 5x minus 1 and x minus 3. So x is equal to 1 over 5, x equal 3. But we need to check all of that possibility. If we check 3, I think still okay, right? And we check 1 over 5 also, it will be negative 2, negative 2, and 1 over 5. Yeah, still okay. So both equations are verified. So this is the solution.
So aquí les tengo que utilizar la fórmula porque yo no sé cómo la solución. O sea, aquí tienes la tabla de solución. No hay cinco.
Okay, that's the first one. We have the solution. And how about the second question? Any ideas to solve that? So I want you to like emphasize here. Basically, the first one, we need to make sure all the things within the equation in the same terms of base. The base needs to be the same, which is fine. And then afterwards, we get the base, same base. What we can do is we can combine if we have like plus, we can multiply the inside 5x squared. If we have minus, then it will be 5 over x squared, okay? So combine everything, and then equaling with these two sides. So when we have like log base of 5, this is also log base of 5. Then the inside, we equaling this, and then we check the x. After we get the x, check one by one through the equation and verify whether it is satisfied or not. If it is satisfied, that's our solution. If not, then we can cancel 1. Like if you have 3, you can cancel like maybe like you check first, and if those 3 is satisfying, then we have 3 solutions. Like this one, I think we have 2 solutions that satisfy. Okay. And how about the second one? The second one, see that we have a division here, a fraction, 10 over 2 with power of y. Remember, in log, the base is 5 here, right? The same base, we make it the same. This is also the base, right? 2 is the base in terms of exponent. They are already the same. So we just combine this together here. Okay? So we will have 2. So we have 2 y plus 1 multiplied by 2 with power of y equaling 10, which means we are going to have 2y plus 1, right? and this will be 10. Now what should we do? Our variable is under power. How we can make it turn down here?
Same base both sides.
Yeah, we take the log. Just take log. Take log 10 is just 1. So we get that this will be log or 2y plus 1. Log 2 is log 10 or 1. So 2y plus 1 is 1 over log 2 or 2y is 1 over log 2 minus 1. Y is 1 over 2 log 2 minus half. Okay. And I think we can just stop until there. You can make sure if you want to use calculator, but I think no need. Just this is okay. Okay.
So that,
Yes.
that solution will be it for the points.
Yeah, it's okay.
I was here.
Okay, next one. Okay, next one is, I think this is easy, right? This one easy or not? Let me give you a hint, but I will skip. The hint is we need to let some variable a, for example, 2 with power of x, and it will be quadratic equation, right? Okay, very easy, right? Okay, we can skip. And then this one, I think I will skip for now. How about this? This is supposed to be simple. Is it simple enough? Because I have 2 more at this more advanced question. Is it simple enough that I can skip, or you need to know how?
Very brief explanation.
Okay, this one is, the question is expressing this part in terms of A. A can be defined by this. So either we can start from manipulating the left part, which is it's 16 is, we can get the base of 2, right? I mean the 2 exponent, 2 with power of 4, right? And 8 is 2 power of 3. Right? So we can have that connection, or you can arriving from here and then getting to here. So we can write, for example, we can write first that the log b 8b as log b 8 plus log b, which is 1, right? So this will be, we can write 2 with 3, and this will be just 1. And from the A, we know that A is this. So A is 4 log B2. So log B2 is A over 4. So this will be 3 log B2 plus 1. And log B2, log base 2, B of 2 is A over 4. So this will be 3 over 4A plus 1. Okay? Very quick, right? So I think the key to understand the log and exponent, usually you need to be aware of the base, okay, and the expression inside. If you see some connections, then you can correlate that. Okay? Use that one. Actually, the question is already complete. I know the question, what question will be. It's only 5 questions. Polynomial and the logarithmic.
For the test?
Yes, the total will be 5 questions.
5 of each.
No, 5 total. 5 in total. Okay. So
Part A, B, C.
So for polynomial, for sure there will be finding the rational zeros. So finding the real zeros, that will be for sure. Okay. For the exponent and log, for sure there will be like solving the logarithmic expression. Okay. That I think, and some like this, like you have like to solve some expression in terms of another expression. Okay. At least one question about like that one. Okay. Which one do you want to take, this or this? Both are interesting. I think this one okay. So the key, always see the base. You always see the base. Base is A, base is A. So you can do something about that. And basically, it's not about the logarithmic equation anymore. Right? It will be, check this and we can make it here and we have another square root, right? And this will be square root and then this will be this. So perhaps you have some equations that you need to solve. It can be quadratic, it can be anything, right? But try to solve it. It's like a more percentage on the algebra part. Okay. But then I will not give like as difficult as this one. Okay. I mean this is, you need to have like more process in algebra, right? But good for exercise. So try first. I think
Is it 20? Very negative.
So if you power it, that's plus 2 square of x in the beginning. Quadratic equation. 1 plus 2 is constant. But it's correct. I mean the idea correct, but the wrong extension.
Okay.
Yeah, I need to solve this calculation.
Yeah, it's almost like
Yeah.
kind of the same, almost.
Yeah.
You just
You can let maybe A or y equals root of x.
Is it like,
You have x of 2 root 2.
and then I was like,
Yes, I know.
No.
So sometimes that is
You just say.
is it 2? No. It's 2 digit.
The half just moves to the other side, becomes a square.
Wait,
What's wrong with those square roots? You don't need next square roots. What's wrong with this one?
Wrong with this one. The x squared. Actually, x.
Oh yeah.
But idea correct.
The first idea that we can like take out of the root that you get
Yes.
out of would be like just square.
Yes.
And then
Yeah. And it's all like a quadratic equation. But it's not quadratic, but it will be a quadratic.
Cancel root of x and then just I should bring materials.
Oh yeah.
Okay, so it would be like in this side would be like 2 root of x, and this side is root of x. So like.
Well, you could just move these two over here, and this will be squared. Right? The same thing. Same thing. Same thing. If you like using this to here, and at the end you square both of them, that's the same thing. Right? Yeah.
Is it 8?
Almost.
16.
Yeah, 16.
Huh?
16.
There's just intro.
16.
No, bro. Can I do that?
16. So first is taking 2 here. I will make this log a, and since 2 is here, I will move on the power. So I will have this, and then I will have another 1, and then let me write. We factor, we expand the expression, and this would be. And remember, since we are in actually this equation is inside the log, which means that everything we do, like square root of that part, and because of the log should be positive, so it's okay, right? It's okay. We manipulate everything inside. So then what will be happening here is we are going to see that this will be, we can solve and simplify it first. 9 and 16, we can get that 4, right? And then this will be, let me write, this will be x plus, so this will be plus 2, it's not plus. So plus 2 square of x minus 2, right? So this will be minus, sorry, 2 square root of x, and then we have 9 and 1, so this will be 9, 8, right? Okay. And then perhaps you feel how to solve this. We can always change the variable, okay? Substitute variable. So let maybe a equals square root of x. So a squared will be x. So we have a squared minus 2a minus 8. And this will be a normal quadratic equations, which we have a minus 4 and a plus 2. Okay, so a is 4 and a is negative 2. But don't forget that a is another variable that we are not incorporated with. So we need to change back to the system, which this is going to be square root of x equal 4, or square root of x equal negative 2. So the negative 2 is not possible, so I will cancel that. And the possible one, only this x, is 16.
Couldn't we, instead of like changing from like a equals root of x, just square it?
How to, you mean
Square the whole.
this one? Yeah, I think this is actually just factorized, but sometimes we make more simple idea of factorization if we put the quadratic part, right? But well, you could directly factorize this, like if you can just directly write this as, for example, just write up like this. Yeah, you could do directly. It's okay. This is okay. This is for someone who are not really familiar with the square root, and sometimes in calculation, especially exam, you'll feel very nervous. So substitution will help. Yes.
What's the root x equal? We just do the check.
You can check.
Oh yeah.
You can check what kind of x that can have negative 2. Okay. If you square both sides, of course it will not help.
Yeah.
Right? Hmm? This one? Huh? We squared. It is square root x.
Yeah. And x is, where is x? Oh, the substitution is the.
Okay, nice, right? Do you think it's a nice question? Okay. Okay, I think we can try. I think this will be the last one, okay, and then we can finish off the. Okay, this is quite challenging, but you can try first.
Let's see.
So this is actually not only about logarithmic, but you will see later it's also about polynomial. But quite challenging. If you get this, no need to worry about Monday, please. But for the quiz, not as difficult as this. Just to encourage you to be more positive. But I think like tips for if you want to improve your math skills, there's always to improve. Like, do not ever think like, oh, that's easy, I can do it. You need to like to prove that always. Like, do not like just keep like skimming the question. Is this is easy. You need to try. You need to try. You need to try, and then whenever you evaluate your own skills, and then you know like, oh, I get it this part, but I don't get it this part. That is the first step of learning. When you know like which part that you are missing out, and that means that you need to like at least rush out to, oh, I need to understand this, and perhaps you can trace like which part that you have been missing out for all the time. Like you can trace out like if you are brings all your knowledge and skills from the previous part of your life and then brings to the future, all those missing out part will also goes to the future, which sometimes you will get some jumbled information which you are not really familiar of. So I think that as early as possible you need to try to find your own limit. If not, then it will be very, very difficult for you to go to the future if you are, because all the stuff that you're missing out, you are going to bring out here, and then like especially for nowadays where the mental health issues becomes more and more increasing a lot, I think. So you need to be aware of that. Sometimes you make like when you are like having those issues like anxiety or perhaps depression, if you cannot help out yourself, then you need to seek help. I mean, find out how to deal with that. If you suppress one, maybe sometimes it will be like it will explode, and not in a good way. And perhaps your environment will also get affected by you. I think one of the factors, because our technology is more and more like sophisticated, and there is no distinction between our real life and then our digital life, so to say. I think that's one factor. Like if
You
they,
reflect them.
like there's like no line in between, like sometimes the line is kind of blurred, and then that will affect our line. It's kind of like the digital part is overlapping our line. So that's why I think for young children, it's best they are not really getting too much addiction to like smartphone or things. If they are maybe old enough, like maybe junior high or high school, I think so. But for like the young children, it's best they are trying to learning from we say analog, using pen and paper. They will have their cognitive skills. Even now, with the AI, I think also like if we are not embracing it correctly, we are going into the like wrong direction, I think. And we are like asking what is human really is. If, for example, if we are making some kind of robot that has like pretty sophisticated algorithm to think and to take decision.
All those things are the same, just the robot just now that it takes Peter on. Basically, it's an AI chatbot of Samsung. It's like a Google assistant for Samsung.
Yeah.
What's
Like the moment you said robot just now, third time.
When you fail.
Yeah.
No.
And sometimes when we speak like this, and you check your social media, the advertisement
Yes.
will be about that.
No,
They kind of finding ways.
I saw that one.
I tried it several times.
Yeah,
We talk about this, and like I talk about one time I talked to the students about how to get motivation from like a Japanese way. They have something called Ikigai, how to find your passion, and then how to work with that. And then suddenly when I check my social media, it's about Ikigai.
One.
That's crazy.
Yes, they hear us.
So it's not really like we are not in a like that's not private anymore. Anyone get it?
We don't need calculator.
We need I know.
4 to the power of 7.
3, okay, yeah. I think we have 3 solutions, right? We have 3 solutions. So what's the first thing we can do?
I also like this.
I think once we get correct, the answer is 2, 4, and 16. How to get that, right? So let me explain. This is first, okay? If we try to write this in this form, yes. So what should we do first? We could substitute. Again, substitutions sometimes will help in algebra, most of the time. Okay, so let's substitute the log for x as maybe a. Okay. So 2 minus 7a. This is 7 minus 2a. And this will be plus a squared. And then we can try to solve this algebraically. So we are going to take this plus a squared, 7 minus 2a equals 0. So we are going to have, what we have, 7a squared and then negative 2a. So negative 2a. So 2. And we can multiply with negative, so we have 2a cubed. Okay. And then what's next? So we can let this become our polynomials with degree of 3. So let a is 2a cubed, or maybe let me write a little bit left. Okay. Then we solve finding the real zeros in polynomial. So it's like 2-in-1 question. Okay. So I think we have 1, 2, 3. So 3 or 2, 1, 3 or 1. So 3, positive 0 or 1. And then if we have negative a, this will be negative 2a cubed, negative 7a squared, negative 7a, negative 2. So there is no negative 0. So perhaps it's all positive. So we can finally, let me just erase all this negative a. We can, so it goes by factor of 2 over 2. So we can have 1/2, right? 1/2 and 2. So we can try to check maybe for 1, 2, negative 7, 7, negative 2. Check 1. Oh, we get it. So the first one is a minus 1, 2a minus 5, 2a squared minus 5a plus 2. And then this one, we can factorize, I think. A, this will be negative 2 to make it negative 4, negative 1. Right? So a minus 1. And then what else? 2a minus 1 and a minus 2. So we have a is 1, a is half, a is 2. But remember, this is still in a. We need to change back to x. So log for x is 1, so x is 4. And this one is half. So half means, let me write here, log for x is half. So 4 with power of half is 2, right? And the rest is 2. 2 will be 4 with power of 2 is 16. So the third one is 16. So that's the answer. Okay, done. Okay, so I think that will be the last question. So on quiz, there will be one question asking to solve the log equation. It means that finding the x. Also, how to write the log terms in another terms, like a, b, like we did before. This will be one question. And the polynomial, the first is finding the real zeros. The second one is the remainder theorem, if you remember. Okay, when we define something, we have some remainder. There will be also one thing to be aware. And I forgot one more question. But I think still in this, like I think solving some simple logarithm, just 5 questions. If you are doing this okay, I think like you can do this 5 questions in less than 1 hour.